Hello guys, welcome to Microlearning Part 1, Cloud Migration using AWS Fargate Elasticache. The objective of this video is to discussing the steps for migrating existing PHP applications using Docker container and replacing their sticky sessions using AWS Elasticache, probably with Redis, and deploying the changes to the Fargate. Here you can see the steps that I'm going to discuss in this video. We will start with the containerizing and pushing the changes that image to the ECR. And from ECR, we will spin up a task using ECS Fargate. The next step is integrating with Redis, which means we are replacing a sticky session using the Redis, using Elasticache and Cloudformation. So basically, we are preparing a Cloudformation file that can be used for scaling up the infrastructure, or uh, which will be helpful for preparing an infrastructure. Before we proceed further, I'm assuming you have a basic knowledge in Docker and have an AWS account and Visual Studio Code Editor. Let's start with containerizing. So, what we are going to do with the containerizing? So, we have a application right now. Then the first step is to containerize that application. In order to containerize, we should have an image that here I'm going to use an image that is from the Docker Hub, and we have a PHP official image available in Docker Hub. Or you can make a custom images, whatever you want. Either way is fine. And I'm running it along with the Apache within that container image itself. In code, we have to add a Docker file mentioning the PHP image and associated commands that we're supposed to run with that Docker build and Docker run. Let's run a sample after containerizing the application, and if it's successful, then push the changes to the ECR. Well, this is the official PHP image which are available in Docker Hub, and I'm taking one of their image from here itself. If you have been pulled this image, then we have to run this command locally. Then only it will pull the images into local Docker Hub. Sorry, local image. I have already executed this command earlier for a demo purpose. Let's check whether this is still available. Docker images PHP. So this is a Docker command, and I'm going to check the images which are available in my system, and I'm particularly looking for the PHP official image. Here we go. Yes, which is available, and the latest tag is there. And yeah, 2 weeks ago, I have pulled this one. Here you can see a sample application I have created using Visual Studio Code, and this does contain only one page, index.php, and which is just printing a hello world. In order to containerizing, we have to add the Docker file first. So I'm going to add a Docker file. There you can see the Docker Hub image. So the first command that we are going to follow is we have to specify the image that we are going to use it for containerizing. So the command for getting the image is like from base image. So we have already seen from where we will get that image. I already have that name. It's PHP 7.2 with Apache. So which means that that particular container does contain the Apache itself, and it will run using that web server Apache. We can customize in different ways, like we can just use the PHP, and we can containerize. We can create a container or the image for a separate PHP, and we can connect whenever we are deploying to our during the orchestration. For the simplicity, I'm using a PHP application using the Apache all together in single container. Now we have to copy all the build files into, or the scripts that we need that we have in this application to the container folder, or the folder where this supposed to run. Okay, so we are using the copy command. So you can see that the source and destinations are available. Right now, we are already in this folder. You can see that this PHP Microlearning, this is the current folder right now. So just put a slash and the destination. So in this container, it is running in this particular folder, like var www html dash. So this is the folder we are targeting to use. This can be changed based on the images, like I assume for CentOS is something else. And the final step is like we have to expose a port that can be used for connecting to this container. Sorry, it's 80. Now I'm going to save it. So all these are completed. So just summarizing it again, I have a application. In order to containerize this application, I have added a Docker file, and I mentioned the base image where we want to have this container created, like, and copying all the scripts or the pages that we have created for this application into this particular folder where we supposed to run this application, and exposing the uh, port. Okay, in order to run this application, we have to first build the Docker file. So it will fetch the image from this one, PHP, and copy all our scripts to this particular folder, and it will make the port 80 available. So we have command for that, Docker build, and we have to tag this particular image. So we are using this argument. Let's name it like PHP Microlearning. Okay, PHP Microlearning, and a delimiter. So this delimiter is mandatory. So if you're aware of how to build, how to use the command for the Docker, then you might be well aware of this syntax. Otherwise, please go to Docker documentation and have a look at it. Let's build. Okay, I have a successful build right now. Now we have to run it. To run the container, we have a docker run command, and we have to specify the port which we need. So port 8080, and the name of the container. So first, while building the image, we have specified a tag, and here the container, we have to specify the name. So PHP Microlearning container. So this is the name of my container, and which image that we have to use for this. Okay, that's learning. That is PHP Microlearning. Okay, now this is running. Let's check in browser. So since this is available in 80, we can give this localhost. Yes, this is now printing the hello world. So we have successfully ran the application from the container. In this Docker desktop, you can see the images that we have created right now, that PHP microlearning. And if you go to the containers, we can see that the PHP microlearning container is now running at port 80. You click on it. Yes, this is running. Once we have the images ready, we have to push the images to Elastic Container Registry. So what is an Elastic Container Registry? Elastic Container Registry is an AWS managed container image registry services, which is secure, scalable, and reliable. ECR, which means Elastic Container Registry, support both private repository as well as public repository. In private repository, we can make it secure with a role-based permission using AWS IAM. In my AWS console, you can see the ECR. There are private and public repository options are available there. And here you can see I have already created one private repository here named as PHP batch test. So let's create another one. So I'm going to create an ECR repository using PowerShell. So this is AWS. We are going to create ECR, and the command for creating the repository is create repository. And the parameter that we have to pass is like a repository name. I'm going to give the name as PHP micro learning. Okay, so there are other parameters are available. So if you take a look at it, if you click on the create a repository, you can see that there are several options are there. We can set the visibility settings, whether we have to make it private or public. Since the default one is selected as private, I'm not going to add anything in my command. And the next parameter is the name. And you can see the tag immutability, which means by default it is disabled. If you want to set the immutability, then we can make sure every overwritten image push may have to maintain the tag that we are specified, or it should create another image with another tag that we have set for. The final one is the encryption setting, whether we have to encrypt the image using a custom encryption keys or the default one. So these are the parameters that are required to create the repository. So I'm going to execute this. Now you can see the command has successfully created a repository. This is the repository ID. So every repository will have a unique identity and a repository name that we have given for, and this is the URL that we can access this image. Let's see, this is available over here. Yes, the newly created repository is available over here. Now we have to push the image that we have created into this repository, right? If you click this repository, then here on top of this along with this other buttons, we can see a view push commands. If you click on this view push command, we can see there are several commands are available to make the changes available in the repository. So there are some differences with Linux and Windows. But since this is a Linux image, I'm going with this Linux. If you notice the commands, the first one is to have the credential. So what is a credential? If you're executing some commands, AWS commands from your local through PowerShell or Bash script, then we have to set some credential to uh, uh, access the repositories or the resources which are available in cloud. Then the rest of the changes are the Docker commands that needs to be used for building, tagging, and pushing the images to this from source to the destination. But let's see what it is. If you go to the IAM console, here under the user, I have created an entry, my AWS. This is my username. So this user, I have for this user, I have added two permissions: full access to the both Elastic Container Registry (ECR) and the Elastic Container Service (ECS). Okay, I have to add this user permissions or set the AWS configuration as permission in my local. Then only we can access the resources which are available in this in this username. Here we are going to check, or I'm going to show you how I have added up. I have already added this in my configuration. If you list configuration, but it's not configuration, it's configure. Yeah, here you can see that I have already set some shared credentials over here using the AWS configure. And if you check for profiles, list profiles, you can see that there are multiple profiles available. One is default and the development. So this is a development is a one which I have shared for accessing the resources under my credential. Okay. So this is mandatory. Whatever operations you are taking or doing performing from your local machine, we need the permission to access that, so that you can set the permission in the IAM. Coming back to ECR commands, so we don't have to do much here. Just copy the commands which are available over there and paste it here. Let's see whether it can log in successfully. We will get a message if the login is successful. Yes, the login is succeeded. You can see the message over here. Then we have to switch back to the other command. So this is the Docker build. Pasting the command here. This may take some time. Okay, this is completed. The third one is to tag it. Pasting it. Okay. Last command. Okay, pushing the images to ECR. This also may take some time. Okay, now this is completed and you can see that log. So this is pushed. Let's check whether this is available right now. I'm clicking on repository. Okay, the image is available right now and flagged as latest. So this is how we are pushing the images to ECR, and whenever we are um, pushing the another image set or after the build, then we will get another image with the latest tag. Next, we have to set up the environment where we can deploy the image that we have built. So we are going to build an environment using ECS and targeting to AWS Fargate. Well, the Fargate is a serverless pay-as-you-go compute engine that lets focus on building the application without managing the servers. And AWS Fargate is compatible for both ECS and EKS solution. Here, when it comes to the ECS cluster is a logical grouping of tasks or the services, and a task is something which is similar to the pods in Kubernetes, where we can run the container images and we can stop pause the running of the container images. The service is supposed to manage the tasks which are running inside the ECS. So, which is similar to if we have configured two tasks to be run in that particular service, then if one task has been failed due to a fatal error, then service is responsible to make sure next task should be provisioned and it should start running. Before starting setting up the infrastructure, let's see what would be our infrastructure looks like. So this is the infrastructure that we are going to use in this example. Here you can see a VPC, virtual private cloud. Inside the VPC, we have created multiple subnet. So one is public subnet, and the next is private subnets. In under the private subnets, we are going to have the Fargate. So the ENI will be there by default when it has the private IP addresses. So the Fargate, which can along with this Fargate, we have the Elasticache Redis, which are also set up under the private subnets. This private subnets can be accessed only through the public subnets. So we can't directly access from internet. We have a gateway. This is the internet gateway that we have set up, and we can see a load balancer is there, which is supposed to uh, access the tasks which are running under this Fargate. Besides that, we have another entities there like NAT gateway. So the NAT gateway is also there if the container does have some setups like when it comes to the Elasticache Redis, it has to run or install the Redis extension before it going to spin up the task or the container. So that has to communicate to the internet. But since this is set up under the private subnets, it cannot directly go to the internet. So that's why we have the NAT gateway for communication. So we will start setting up VPC first. To set up a VPC, we can search for VPC over here, or in my console. This is available since I have recently visited this to set up. So I'm clicking on VPC. Going to create VPC. I'm selecting VPC only. We will go step by step. Okay. We have to give some name like VPC dash PHP learning. Okay. We have to give the zero manual in zero IP. Okay, so let be 10 points 16. So we have to create multiple subnets for this. Okay, tenancy, we don't have to do anything now. So let's create the VPC right now. Okay, now we have successfully created the VPC. Here you can see under this VPC, we have to create subnets. So like we have public subnets and private subnets. So we will create both of them right now. Click on subnets button. Okay, just ignore. I have a lot of other subnets are created. Okay, so create subnets. For creating the subnets, we have to select the VPC ID that we have. So along with this ID, we can see the name that we have given for. So ours is VPC PHP Microlearning. I'm selecting that. And here we have to create the subnet settings. So we will start with PHP Micro Learning private 01. Let's create two subnets for each of the just like public or private. So availability is on. I'm selecting the first one, and it should be 10.0.1.0.24. Okay, then add another one. It's private 2. It should be E and 10.0.4. So now we have created multiple subnets for the private. Let's create for public. So one availability zone again. 0.0. It's 02. 1B and 4 should be the last one. 02. Okay, so we have created 4 subnets, 2 for each private and public. Let's create. Okay. Okay, now we can see 4 subnets are created, and it's by default these filters are added. That's why the other subnets are not visible right now. Next, we have to create an internet gateway. So let's create a separate one. Internet gateway PHP learning. Okay, now we have created an internet gateway. Going to internet gateway, and as you see in this diagram, we have to attach the internet gateway to the VPC. Here you can see that the newly created internet gateway is marked as detached. The state is detached. We have to attach this to the VPC. So I'm clicking right now, and under the action, we have an option to attach to VPC. Here I have to select the VPC. So I'm selecting my VPC. Now you can see the status attached. Now we have to set up the routes that will manage the route to the internet gateway or the local routes. So where we have to redirect the traffic. In order to create the route, we have to click the route table. So here we have to create public route table and private route table. So first we will create the public route table and attach the internet gateway over. So let's create the route. So creating the route table, let's give RT public PHP ML. Select the VPC. So this is my VPC. Create route. Now I have created the public route. Then under this route, you can see a default one, the target to the local. Now we have to route the traffic which is anywhere other than this local route to the internet gateway, because the internet gateway is the one which is going to talk to the internet. Edit the route and add another one. So this indicate anywhere, and the target is internet gateway. So once we are selecting the internet gateway target, so it will list all the internet gateways which are created under the specified VPC. So this is the one which we have created under the VPC. Select and save the changes. It may take some time. Yeah. Now we can see there are two routes are available. One is local, and all other than local will be redirected to the internet gateway, and the status is active. Once we're done with the route, we have to associate the subnets. So here we can see that all the subnets are attached under the VPC by default. We don't need all of them. Since this is a public facing route, then we have to select only or associate only the public subnets. Let's select only the public subnets. Save associates. Now we can see the subnet associations. We have only two explicit subnet associations are there. So this will be only taken care during their run. Okay. Now we have the public route. Next, we have to create private route, because we have to communicate with the Fargate. So another creating another route table. So this would be similar to the public one. So RT, yeah, it's private PHP ML. I'm selecting the same VPC and creating the route table. Okay, we don't have the routes available unless we create the net gateway. So let's associate the subnets first. Only the private subnets are there. Selecting private. Save associations. You can see this associations are here. Okay. So we have successfully created both the route tables. So I'm summarizing the steps that we have followed till now. We have created a VPC. Under the VPC, we have created 4 subnets. 2 of them are dedicated to private, 2 of them are dedicated to the public. And we have created an internet gateway and attached that internet gateway along with the VPC that we have created. The next step is we have created a root table. In root table itself, we have two entries. One is for the private and one is for the public. For the public root, we have mapped the internet gateway under the root and selected the subnet associations with the public facing subnets. The for the private root table, we have associated the subnets which are associated to the private. Okay. Next, we have to set up net gateway. So the net gateway comes under the public subnet and which is supposed to communicate through the internet for the installation of if it is an npm build, then npm installation, then we have to communicate to the internet. So the net gateway is supposed to communicate with that. So we have to set up the net gateway. Switching to net gateways tab. Here we have to create the net gateway. So PHP ML NAT gateway. So we have to select the subnet. So here you can see from the illustration, it comes under the public one. So we have to select the public. So let me try to, yeah, public one. This is my favorite 01. Okay. We can create multiple NAT gateways for different availabilities on. But now I'm creating only one. So the connectivity type is public. Then we have to allocate an Elastic IP ID. So we can click on allocate Elastic IP, or we can select from the one which is already available. Let's allocate fresh one. Okay, so you can see that an Elastic IP addresses is allocated. Creating the NAT gateway. Yes, it's successfully created. Now we have to attach this to the private route table, since we have to redirect the traffic using the route table. So this one is created under the public subnet, which is supposed to communicate with the private route table. So we have to select the private. So this is our private. Selecting that. Okay. Here we have to edit the routes. Adding the route. So from anywhere should target to NAT gateway. So this is our NAT gateway. Save changes. So along with subnet association, we have the root. Next, we have to move to creating the application load balancer, which will be the only accessible point to access the tasks which are running under the AWS Fargate. Let's create a load balancer. Now to create load balancer, we have to move to EC2. Clicking on EC2. In EC2, you scroll down, you can see a load balancing section. Click on load balancers. Okay, I already have one load balancer, but we are going to create another one. So here you can see there are three type of load balancers are available. application load balancer, network load balancer, and gateway load balancer. So we are going to select application load balancer. We just have path-based routing. So selecting the application load balancer. Now we have to give a name for it. So load balancer HP learning. Application is a bit slow. Okay. So this we have to select the scheme. So this one is going to communicate with the internet. So we will select the internet facing. And in the network mapping, we have to select the VPC. So our VPC is PHP Microlearning. So this we have to select the mappings. So there are two availability zones mentioned. Okay, make sure we have selected the public and the security group. A security group is a virtual firewall. It's acting like a firewall, which controls the incoming and outgoing traffic. So wherein we can set the set of rules for both inbound and outbound controls. So here we can see that a default security group has been assigned. Let's remove it and create new one. You have to give a name dash learning. We have to select the VPC, and here we can see that inbound and outbound rules. So inbound rule we have to add this port 80 anyone. Let's create the security. Oh, created the security group here. Dash. Okay. So we have selected the newly created security group over here. The next section, we have to configure the listeners and routing. We can see that create a target group. So what is a target group? A target group is the one responsible for telling a load balancer where it should route the traffic. So it can be IP address, instances, or some other configurations are there. So based on the sector schema, where to route that traffic to. Here we can see that we don't have any uh, target groups has been available. So we have to create a new one. So here you can see that we have the configuration options are available right now, and under the basic configuration we can choose the target type, whether it can be instance, IP address, lambda function, and application load balancer. Here in this target type, I would like to select the IP addresses, since you know that the ECS will create the task based on the address range that we have configured for the VPC. So we have to make sure the load balancer is routing the traffic to the associated IP address ranges. Now we have to give a name, target group. Okay, so the default is HTTP 80 selected, and we can see that associated with the other HTTP one would be fine, and health check, the default path would be fine. Or if we can, if we have a health check uh, page as a separate, then we can mention that. Uh, so that would be routed to that page for the health check. Let's go to the next page. So here we have to choose a network. So we don't have to specify any static IP over here, since this would be dynamically selected based on the IP range that we have specified in that VPC. So just leave it here. Make sure the port is 80. Create target. Okay. Now the target group has been created successfully, and we can see the newly created target group is available here. PHP Microlearning. But here we can see that none of the load balancers are associated to this target group. Select it. So we can see that a load balance section, associate a new existing load balancer here. Okay, I think we missed one step. We can ignore this one. Since we are about to create the load balancer, we can refresh it over here, and we can associate. Now we have mapped the uh, target group, the listener. We don't have to do anything else. We just we can create the load balancer right away. Now you can see that a successful pop-up is appeared, and if you click on that view load balancer, that a load balancer is available. Now the state is provisioning. It will change to the active. Okay, now we are moving to create Amazon ECS Fargate. We have the image, we have the network setup. Let's create the ECS. So ECS has primarily two things that we have to take in care, like clusters and task definition. As I said before, the ECS has three sections: the clusters, the service, and the task. So the tasks are running based on the task definition. Let's go to the task definition. So the task definition, we can define the images that we are supposed to run the task, and the network configuration and the port mapping. All these informations will contain in each task definition. So let's create a new task definition. So the first, we have to select the launch type. Here you can see that three options are available right now. One is Fargate, EC2, and whether it's an external container. Let's select Fargate because we are dealing with Fargate in this example. So the next step is like we have to configure the task with the containers. So first we have to give a name. So it's cd php ml. Okay, let it be like that. Since we have selected the compatibility, this is already been selected as Fargate, and this is not editable in this configuration section. And we have to select the task role. there are two the default options are available. It's none or ECS task execution role. So ECS task execution role is mandatory. Otherwise, we have, if you need additional configurations for based on the task role, then we can configure it through IAM console. The network mode AWS VPC, since all these through are managed through VPC and we don't have to modify it. Our targeted operating system is Linux. So the next step is setting the task size. So here we have to pay attention by selecting the task memory and the CPU. So here you can see that we have several options available for the task memory and the task CPU and the container definition. As I said before, in each task definition, we can specify multiple containers to be run, and we can split this memory and CPU for each of the container. So here I'm only selecting the basic one. Well, this would be enough for our demo. And we have to specify the container definition. So basically, we have to give the image URL from where it can get the image for setting up the task. We will start with the container name. It's PHP Microlearning container and the repository name. Since we have pushed our latest image into ECR, we can get the URL from here. ECR repository is my PHP Microlearning. And if you click on the latest tag, then we will get the URI. I'm selecting URI, I'm pasting it. Okay, we don't have to set anything for this private repository authentication in this example. And the memory limits. We have two options available here, soft limit and hard limit. So based on your requirement, we can set the memory limit for each of the container that we supposed to add in task definition. And port mapping, I'm mapping the 80. So I'm just ignoring advanced container configuration such as health check, environment, container timeout, network settings. All these are not relevant in our example. So I'm just leaving as it is and I'm adding the container. If you want to add multiple containers, we can select add container again. If you want to add the volumes for each of this container, we can add the volumes here, but we are not going to add volumes in this example. So let's create the task definition. Okay, the task definition has been created successfully. I'm viewing the task definition. So here you can view all the changes that you have made for creating the task definition. Okay, once the task definition is ready, this is the time to create the ECS clusters. So I'm clicking on is creating the cluster. So here also we have three options available: the network only, and the EC2 for Linux, and EC2 for Windows. Since we are targeting to the Fargate, then we can select the networking only. Since the Fargate is a managed serverless environment, so we just have to select the networking only. So the next step is we can give the cluster name. It can be PHP ML cluster. And we don't have to create any separate VPC for this cluster for this time. So let it be like that and create the cluster. Okay. So this is the cluster that we have created. Under the cluster, we have two other options are available, and we have to taken care of is service and task. So all the tasks are running or managed by the service. So we have to create the service first. However, there are options to create or update services. through the task itself. Once there is an update option is available, once the task definition of the task has been created. So this configuration is targeting to the Fargate, and the operating system is Linux. And the task definition, since I have already have two task definition, we can select the one which we are going to use here. And cluster is PHP my cluster, or if it should target to any other cluster, then we can select that. And service name, it's PHP ML service. So here we have to specify the number of the task. So the service will make sure the number of the tasks that we are specifying in this configuration will be up and running always. So if I'm going to give 2, then service will provision another task when one task has been failed. So let it be like this: deployment, rolling update. Okay, and the next step. So the next step is we have to configure the network for the service. So since this is coming under the newly created VPC, then yes, Microlearning VPC and subnet. So during selecting the subnet, we all know all the tasks are going to be run under private subnet. So we can select the private subnet. This is public and this is private. And we have to select the other private. This is public and this is private. Yes. And since this is a private one, then we don't have to use the public IP. Okay. Now the remaining thing is the security group. So this is also relevant. Like the next configuration is for the load balancer. So I'm leaving this right now. And we have created the application load balancer here. So the load balancer name is already been auto populated since we already have created. And the container port, so this is 8080 that we can add to the load balancer. So adding to the load balancer, have another section like production listener port. We already have this listener port, so we can use it 80. And we already have created the target group. So it is the target group that we have specified. So all these are completed, but we have left this security group like this. So here you can see that our task, the running task, can be accessed through only through the application load balancer. So here the VPC and the security group should be the security group that has been assigned to the load balancer. So I'm going to edit the security group, and I'm going to select the existing security group. So here we can see that the load balancer security group has been auto populated here along with the default one, and I'm selecting the load balancer security group. Here we can see that the inbound rule for the selected security group is like it is accepting all the requests which are having the port range with the 80. So which is fine because from any source we can access it. Saving it. One thing I would like to highlight is like if we have a specific health checkup grace period is there, we can set it up. We can set up the auto scaling here, but I'm just leaving it like this, and we can review the configuration and create the service. Now the service has been created, and if you are viewing the service, then under the service it's navigated to the task. So here we can see that 2 tasks are listed under the task. So like I said, I have given the 2 minimum task is there. So the service is provisioning the task here. So the last task is provisioning, and the desired status should be running. If it is failed, then we have to revisit the configuration, or we have to check whether there is any issue with the container image. Let's wait for some time. I'm pausing till the status is changing. Okay, now we can see that the status is running. So the task is running, which means we can access it through the load balancer. Let's move to the load balancer. So here we can see that this is the load balancer that we have binded to the service, and this is the DNS name. We have to copy this DNS name. Let's try it. Okay, this is working. We can see the hello world. Just to summarize, we have created the task definition. Under the task definition, we have configured the compatibility, the operating system, the roles, and the task size and the container that we're supposed to run on each task. Once the task definition has been created, we have created the clusters. And under the cluster, we have one service and two tasks. Once we jump into the cluster, we can see that two Fargate tasks are running and one service has been created with the Fargate. So the service status is active, and under the service, we have a load balancing details is available and the network access and task details. So each task has their own ID. So if we click on this task, we can see the details, the container details, and even the logs. So all these are available. This is health check details. Okay. So that's all about the ECS configuration and deploying the application. Let's configure the Redis. Now let's talk about managing sessions. So here in our existing application, I have made some modifications, just adding two extra pages, login and logout. So here we are assuming adding the session in this application. So mostly there are a lot of available options to save the session, such as storing in a file, proxy, load balancer, or even a database. In this example, I'm storing the session in a file. So and after containerizing, if I'm running the application, you can see that a login page has been appeared and two text boxes are available to enter the username and password. Also, I have added a logout button here. So once it is successfully logged in, then we can see a welcome screen and the logout. If the user clicked on this logout button, it will clear the cache. So that is the working. So before jumping into this one, let's see what is inside this Docker. So I'm going to execute this command. So this will bring us to the folder which is inside the container. So we are right now. You can see that this folder name. So this is the one which we have specified in the Docker file. So we know that our application is running under this folder. So although when there is a session, then the session will be added to the temporary folder. So if you are listing the temporary folder, I already had one session in my previous run, so that's why we can see that. the session over here. So let me clear it before go. I'm pausing for a second. Okay, I have just cleared all the sessions which I have opened earlier. So there is no session is coming. So when the login page is added, then I'm starting a session, and it's validating a username is fake and password is 1234. So if it is successfully logged in with this using this username and password, then we can see a welcome message. Otherwise, it will display a wrong username or password. So let's start the page. Now you can see the login page, and username is fake and password is 1234. Okay, now we can see that welcome fake message has been appeared since the username we are printing the username in along with this welcome. If we navigate and the application, okay, now we can see the a session has a session has appeared under this temp folder. So basically, this is saved in a file server. So it's listing the session based on the from the file. As we all know, this session is configured in the php.ini using the session handler as well as path. So based on that path, it specified the temporary folder, and the handler would be the file. Now we have to change it to the when we are migrating, we are targeting to change into the Elasticache. So there are two options available in AWS Elasticache. One is memcached and Redis. So as per AWS documentation, memcached is the best one to go with. But however, I'm using a Redis. If you want to have a large number of sessions, or we can have used where people mostly prefer a Redis because we can widely use it for the database as well. So in this example, we are going to have the Redis. Now let's set up Elasticache Redis. We are moving to the AWS console and going to set up Redis. Before we jump into the console, let me explain what we are going to do in following slides. Like first, we have to set up the Redis. So in Redis, there are two sort of settings. The first one is cluster mode on, and the second one is cluster mode off. So in this demo, I'm going to set up Redis without cluster mode on. The second change is going to modify the php.ini for session. Like I mentioned earlier, when I'm explaining the session stored in a file, so it is managed by the php.ini. So in the php.ini, the session handler would be marked as file. Here we have to change into the Redis if we are not using cluster mode on. If it is a cluster mode on, then we have to change it to the Redis cluster. The next change, since we are adding the Redis in the Elasticache Redis into the same VPC or another VPC, then it is not available it is not available publicly. In order to access the Redis, we have to add the port number in security group. So we are going to set up this Redis in a security group. So we have to add that in the private subnet. Also, we have a VPC pairing. We have multiple ways to connect to or set up the Elasticache. One, we can accommodate Elasticache Redis inside the same VPC, which is what we are going to discuss in this example. And other way, we can add in a separate VPC. So if it is in a separate VPC, then accessing from the internal network, then we have to peer the VPC. So that is called VPC peering. So again, I'm back to my console. Let's search for Elasticache. Okay, clicking on Elasticache. Okay, under Elasticache, we have several options: Redis cluster, global data store, memcache clusters. So here we are going to select the Redis cluster. Even though it names like Redis cluster, like I mentioned earlier, we are not going to enable the cluster mode. Oh, so we have a create button. We are going to configure and create a new cluster. We don't have any backup yet, so we are going to configure it as a new. And this is the one to choose whether we need to make it the cluster mode on, enable, or disabled. Like I said, we are disabling in this example. So if you want, you can enable it. And this is the cluster info. So we have the option to add the name. Redis cluster PHP for learning. Okay. Location, it's AWS cloud. It's not on premises. And auto failover is automatically enabled. So here we can see that this is a port number, the default port number that we are going to use for connecting to the Redis 6379. And here we have the groups that can control the runtime. So if it is a cluster mode on, we can select cluster mode on. Otherwise, if it is node only, then it's Redis. Now we have to select the type of the node. So here we have to pay some attention, like based on our demand, we have to choose appropriate node type. So in this example, we don't need any huge volume. We are not expecting any huge volume data. So I'm selecting only cache T2 micro. The number of replicas, yes, I'm keeping the default one. And here we have two options. Like we can choose the existing subnet or create the new subnet group. So here I'm going to create a new subnet group. We can select the VPC here. So it would be Redis ST micro learning. Okay, let it be like this. And we can choose the VPC. So selecting the VPC. Oh, sheesh. I don't know the name. Okay, so let's find out what is a VPC ID. Okay, now let's see what are the now the list of VPCs I have created so far has been listed here, and the VPC which we want is this one, PHP Microlearning, and here we can see the VPC ID column. So we have to see OZ. Okay. OZ. Okay. Now we have to choose the availability zones. So, these are the subnet. So here we can see that these are the subnet that we have created so far with this VPC ID. But we know some of them are public and some of them are private. So here we don't need the public one. Let's find out. Private 9655 9655. These are the private one. Oh, it's hard to find. Let's filter it. PHP micro learning. 96 and 55. 96 and 55. Okay, now we can see that it's reduced to this. And availability zone replacement, I don't have any preference. So let it be like no preference. Encryption at rest and encryption in transit. So if we enable this this one from our application, it would be we have to pay an attention, like we cannot connect to TCP. We have to use TSL with the auth code if we enable this one. So I'm not have this transit right now, and we have to select the security group. So we don't have any security group right now. So let's create one for the okay. So this is one we have selected for, like manage. Okay, we don't have that security groups created. So create a new security group for that. Sorry, is G. And inbound rule we have to leave right now. We will keep it like this. We will modify it later. Security group. Oh, we have to add the description. There it is. SG. That's this. Of the security group here. Okay, backup. We don't need that right now. Oh, and show logs. Let's leave it like this. So we are reviewing this and create. So this may take some time. I'm pausing for a while. Now the cluster was created successfully, but the status is creating. You have to wait some time. Okay, after a few minutes run, now we can see that the status is available right now. If we go inside, we can see one primary node is available and two replica, and we can see cluster mode is off. When we are trying to connect to the Redis, we can use either a primary endpoint which has the read and write, and the reader endpoint. If we need to read only, then we can use this reader endpoint. The next step is we have to prepare our code to accept the to connect to the Redis. So in order to that, we have to do some changes in the Docker file as well, because to connect to the Redis and work with Redis, then we need to have an extension is available in our container. To get that extension, we have to install a Redis in container itself. So we should have a command to install the Redis. So the command is run and install Redis. So this is a command to install the Redis. Let's save it, build the solution again. Okay, now we can see that the installation command is running. It's installing Redis. Okay, now the installation is completed, and I would like to add one more point. So, hope you remember we have added net gateway in public subnet, and I mentioned which will be helpful to communicate to the clouds, to communicate to the internet. So, once we have this integration command, then it has to reach the internet to download the files which are necessary for the Redis to be installed in the container. So that NAT gateway will help to do that. Now we have installed the Redis, but still the session is pointing to the file. So we have to update the php.ini file. So what we have to do that? So there are multiple ways. So the one way is to add or modify the script before we start the session to point to the Redis. Otherwise, we can add the php.ini file itself. So here in this example, I'm following the second option. Okay, here you can see that I have created a php.ini file and copied the existing file from my another solution. But here in this particular line, we can see that extension I have marked as redis.iso. So this is mandatory to work with the Redis. The next, in php.ini, under the session, we have the session.save handler. So this should be marked as Redis, or if it is pointing to a DB, then it should be a DB or a file. The next thing is we have to add the save path where we supposed to store the session. So this path would be the path that we have that we will get from the Elastic cluster. So in console, we can see that under the Elasticache, we have the primary endpoint and the reader endpoint. I'm going to select the primary endpoint since we have the read and write, and going to paste it to the php.ini. So this is a path, but we have to add as a mode of communication. Also change the in php.ini. Next step is we have to use this php.ini in the container. In order to do that, we have to replace the existing php.ini with this one, or we have to put this php.ini into that particular running folder. So back to the Docker file, we have to add one more step here to copy that php.ini. So we have to add a copy command here. The source should ini should be like this, and the destination is a PHP folder inside the container. So here I have already listed the particular folder which is having that php.ini and the config.d. So we have to add that. It's user local etc php. So this should be the folder that will have the configuration file for the current PHP application. So in this section, we have added two additional commands. One is to copy the php.ini and run and install Redis extension. Let's run it again. I'm going to build the application. Yeah. Oh, I think I forgot. Let's do it. Okay, I have built this one successfully. If I'm running this image again, I should get an error because it couldn't establish a connection to the Redis. That's right. It's taking time because it's trying to have a connection with the Redis, and the retry options are there. So once after all this retry option, then the page will be displayed with this error. So which means it cannot connect to the it is not able to make a connection to the Redis cluster. This is fine. So once it's deployed to Fargate, then we will have it ready. So the next step is to have this changes into the Fargate. So we have to push these changes to the ECR, and we have to rerun the task. So running the task and pushing the changes to ECR, I have already explained in previous slides, so I'm not going to repeat that changes. Repeat those here to save some time. So I'm pausing till I rerun it. Okay, I have successfully pushed all these changes into the ECR. Now I have to rerun the task. So I was doing other thing I just turned off for this task. I'm just updating the service with the nodes that I need. So since we haven't completed the task setup yet, it should fail because of we haven't enabled the port to be communicated with the private network. So let's wait for some time to run this task. Now you can see two tasks are up and running. So let's try to access the application. So I'm searching for the index page. It should work. Now you can see running the hello world, but it will not work with the login page since we have to enable the port communicate with the Redis upgrade. In order to enable the port, we have to go to service. If you click on the service details, we can see that the security group which is created under created for the service. So let's open it. Now I'm moving to the security groups, and the security groups earlier I have assigned for the ECS is the same for the dot balancer. In order to make it easy to work with the ECS, I have straight away given the security group for that I have used with the load balancer. But here I'm going to add a further separation, like we will have a dedicated security group for the ECS, so that will enable the load balancer to communicate with, as well as we have to add the port range in that particular security group. Since we already have created this ECS, then we cannot modify the security group. So I'm really sorry I haven't mentioned this earlier. So if you have followed this till this video, you can create another service for that with the following changes. We cannot update the security group once it's been created. So I'm going to create another service for this. So I'm going to repeat all the steps which I have created, which I have done during the creation of service, except selecting the security group. So I will explain only that part. So here I'm going to create, here I'm creating a new service. So I'm following all the steps which I have done while creating the earlier service, but only the difference is selecting the security group. So in earlier example, we have selected the existing security group. So I have used the one which we have used for the load balancer. Now I'm not going to use the same one with the load balancer, but I'm going to create a new one. So we have to add the a security group name. So this is for the ECS dedicated service group. So it's SG. And it should go with this HTTP type and TCP 80 anywhere. This is the default one. So this is the exact replica of what we have in the load balancer. However, we need to restrict the source from the load balancer, because uh, we are going to restrict the access to the load balancer, since this is under the private network. Earlier it was since it was same as the load balancer, we don't have any restriction. So the source group, I have to select the source group which we have it. I believe it was entered with the 43. Okay, it's 43. Now we have one more rule to be configured. So it should be custom TCP. Custom TCP, and the port range should be 6379, and the source group, okay, I don't actually remember. Group 7F7. Okay, so I have added the Redis as well. Save it. Rest I'm skipping in this video since it was the same as it would be the same as the earlier one. Now we can see two tasks has been started and running. So let's check whether we could access to the login PHP. What's giving any timeout? Okay, we are getting a gateway timeout error. So let's see what I have missed to establish the connection with Redis. Now we have added the, you look at the security group, have created a security group for ECS, and inbound rule, we have two inbound rule. One is for the load balancer and one is for the Redis cluster. Okay, so let's check the security group of Redis cluster, whether it's accepting the inbound rule of this security group. Yeah, we don't have any inbound rule for this security group. So right now, it doesn't know how to communicate with the incoming request. So let's add a new rule. So here is custom CP. The port range is 6379, and the source is custom, and we have to add the security group of ECS, because ECS is only one going to communicate with the this Redis right now, and save the rule. Now we have saved the rule. Let's check right now. Okay, now we have, okay, now this is working. It's saving the session in Redis cluster, and if you log out, then we can see that we have cleared the session. Okay, so that's all about connecting or changing the file session into the Redis cluster. In order to summarize, we have created a Elasticache. We go to our Redis cluster, we can see the cluster that we have created right now, and we have disabled the cluster mode, and only one shard is available, and total three uh, nodes are running. And when it comes to the ECS, we did a major change. Like previously, we have created a service with the uh, security group as the load balancer. Now we have changed into as another security group that is having different. Here in the security group, we can see that I have changed the inbound rules with limited to the load balancer, as well as the Redis security group. For the Redis security group, I have enabled an explicit port range that's supported by the Redis. So these are the changes that we have did to make it work. Let's move to the slide. So we are moving to our final section, setting up CloudFormation. So, AWS has a service which can be used by the developers or the business to make an easy way to create a collection of related AWS resources, as well as information of third-party resources that we are used in this cloud migration or in the cloud setup. So basically, this cloud formation is a template wherein we can specify the resources and the parameters that are needed by those resources. So through this resource, we can create a separate resources while uploading these resources or executing it to a stack. So we will come to a stack. What is stack later? So the cloud formation, as I said, there are several parts that we can use for specifying the resource and the metadata information that regarding the resources that we have. So how does this cloud formation works? The cloud formation creates a bucket, S3 bucket for each of the region. So it's basically working with a region. So we can upload a template file, or we can create the cloud formation using the resources which are available in their own designer. So we can access that designer from a stack, and we can download the created template file, and we can keep it and reuse it during other deployment process. So it will make their DevOps job easier, and we don't have to make any further changes to setting up a exact replica of already existing resources, and we are keeping all those information in the cloud formation. Okay, now we can see in my console in US East one, I have created a stack. So this stack is something similar to a wrapper around the resources that we have. So through this wrapper, we can create or modify or even delete the resources that we are creating through the stacks. So in this stack, you can see I have created one stack. So if I click on the stack, you can see, go if you go to the template, you can see the template which I have created for this. So this is nothing but I have tried to recreate the same resources which I have used in our demo, like a load balancer and ECS cluster with Fargate, as well as Redis. So we have a connection and VPC, all those informations which I have used here. So now, if you're simply seeing this template, then it may not make any sense to you. So we have a designer for it. If you go to designer, yes, we can see how these resources are connected, as well as the resources which I have created. So I'm just zooming in. So here you can see that a VPC, a subnet, a route table, a subnet, public route, NAT gateway, move, Redis Elasticache, um, security group. This is Redis Elasticache, and task definition. So everything I have created here. So it's all through this template. So here I can add. I can simply explain what it is. So like I said, there are common sections which are available in this template. So one is the format version, another is the metadata. So the metadata is just an information regarding this view, and the parameters. So in the parameter, I just like in programming language, we can it's similar to defining a variable. So when it's considering the VPC creation, this is the CIDR I have created for the VPC. So if you go and check in a resource during the creation of VPC, in the CIDR block, I'm referring what I have created in the parameter. So we are already creating the parameter, and we are reusing it with the reference. And you can see that type. So this type is mentioned in their documentation. So we have to find out the appropriate type for each one, like internet gateway, attachment, or the subnet group. So everything, they have their own type. So we through this type, they can decide which a resource is going to be created, and each resource has their own properties. Besides this reference, they have intrinsic functions such as get attribute and get location, like availability sounds. I can explain that. So here in AWS documentation, under AWS Cloudformation, we can see a user guide. In this user guide, left side, you can see the template reference. So basically, this template reference has all the information that we need to build up a template, such as if I'm creating an ECS, then if you expand or click on this ECS, it will load the resource type. Here we can see a lot of resource types are there: capacity provider, cluster, association, primary, task set, service, task definition, task set. So all these resource types are there. We have to add the appropriate task type in order to setting up an ECS, such as an ECS need a task definition. So if you click on this task definition, we can see the task definition type here. So these are available in two types, JSON and YAML. So both these examples are available in their documentation. Since I have used the YAML, I'm moving to the YAML file, and each resource have their own attribute or properties. So in this property, we have to mention as it mentioned like this, and each of these properties has their own documentation. So if you click on that container definition, it has a description, so what it's supposed to do, and whether it's required or not. And sometimes you have to take care of, like the required flag is no, but in the documentation or the description, it has mentioned like some certain conditions it should be available or it should be mandatory. So we have to try it accordingly. So here we can see that the type, the supported type, here it's string, but here it's a list of container definition. So the container definition is something other other resource type. So if you click on this container definition, we can see the format which it's supported. So either we have to create this type, or we have to add it other along with this one, container definition, like it's supporting a list of container definition, so we have to add it. And in each page, we may have the examples that we need. So it would make our life easier, since the readily available examples are there, and I have return values. So in this, we can use the reference, so which can be used as a reference, and the list of properties that we have. The next is their own functions, so which are intrinsic function. Intrinsic functions. So if you search for intrinsic function, the function reference, yes, we can see the available functions are there. So if you click on this get attribute, so basically this get attribute is getting the property names or property attributes that we are specifying for each of the resources. So we can, if you want to refer this, then we can add it. To run this example, I don't have anything to be saved. Then we can see the result in stacks. Now you can see that this has been completed. So if anything failed, we have the policy to roll back every changes or every resources that are successfully been created. I will create another video for detailing about the creation and execution of Cloudformation with the same resources probably. So I'm not going deep into the creation and maintenance of Cloudformation in this video, but I will add this Cloudformation along with this project. So I'll add into a GitHub repository, and I will mention the URL in the description so you can play around with this example. Thank you.